Assalamu alaikum. My name is Usama Mahmood, and today I'm going to present a small tutorial for Solidity programming language for building Ethereum smart contracts. So I have given the following points to cover in this tutorial. Talking about the environment setup, I'm going to use the Remix. Remix is an online. Let me open Remix. Remix is an online IDE for compilation and deployment of Solidity code on virtual machines or external resources like JavaScript virtual machine or MetaMask. For this tutorial, I'm going to use JavaScript virtual machine. So let's go ahead. First of all, I already told you about environment setup where I'm going to use Remix. Coming to the basic syntax of Solidity programming language, here I have already written the code for all these points to lessen the time of the video. It will shorten my and your time. So coming to the some basic syntax of the Solidity programming language, first of all we have to write the version of Solidity. Pragma Solidity first line defines the version of Solidity. Now my compiler is already alert that I'm going to use the Solidity version for 0.4.0, but less than 0.6.0. So then I have to write the contract. This contract is a reserved keyword. Let me yeah, I'm doing recording. Contract is a reserved keyword for the Solidity. Then we have to write the contract name. I used a simple storage, then some variables, functions, and blah blah blah. So coming to the if I let's say let me write a context contract demo. This is the basic syntax of Solidity programming language. Contract reserved keyword, contract name. Then we can write here the code like we write in other programming languages. Like we have to write variables, functions, and our code logic behind this. The next step is first simple smart contract. First simple smart contract. Okay. Here is the first simple smart contract. I already told that first of all we have to write the version number. Here I mentioned 0.5.0. Then the basic syntax of the Solidity programming language. Here I declared the constructor for this contract. In the constructor I haven't wrote anything because I have no variable here. Let me create a variable called doing 1 2 3, and then in constructor I can initialize it where 1 2 3 is equal to 5. Then we have a function here, get result, or here we have some local variables and a return. Oh, let me compile this. I successfully compiled my code. Now I have to deploy the code. For this, I'm going to use JavaScript virtual machine that I already told you. So let me deploy it. Okay, I have deployed the code. Simple storage and deployed Solidity test. Here is the Solidity test. Get result function. Now, if I call get result function, here I have a call, and in the result function, here I have the value 3. The 3 is the result of 1 plus 2. So I have successfully compiled and deployed my code on Remix IDE. Coming to the next step, that is comments. As we write comments in JavaScript or C++, same is the syntax for a Solidity programming language. We can write the comments like here. A single line for the single line comment, we can use double slashes. For the multi-line comments, we can use backslash, forward slash, static, and static forward slash. We can use multiple line comments. This is the basic syntax of the code. Coming to the next point, 3 or 4 types. Here are the types. just like other programming languages, we have certain types in this Solidity programming language. Here we have a Boolean type, that is true or false. Integer type. In integer type, we have two variations. One is int and other is uint. Int is for signed bit and uint for unsigned bit. Then we have another integer version, that is int 8 to int 256. This is the signed int from 8 bits to 256 bits. This is the way uh, we use memory efficient code. Just like we use longs for long in C++, we can use int 256. Here we have unsigned int variation and an address variable that can store the 80 bytes value representing the address of an ETM. Then we have some other variable types, that is state variable and local variable. Just like we have local variable and global variables in C++, we have state variables and local variables. The state variables are those variables whose values are constant and cannot be changed, while the local variables are temporary variables. These variables are only initialized and declared in the functions, while the state variables are declared in the contract scope. Here I have created, this is the access specifier that I initialized public. Uint type 8. Okay, here's the variable name. Here's the constructor. Here I'm initializing the state variable. Here's the function that is returning a unit type. It is returning the state variable. Here's another function called get result. It is also type. It's also returning a unit type result. I'm creating two local variables, then summing up and returning them. Uh, Let me compile it. Compile style dot source. Then deploying it. Okay, I have deployed it. Let me check. Is the uh, Solidity var test. Solidity var test here. Here I have three functions. Uh, One is the previous function, so get state var and get result. Okay, get state var. Here is the get state var event 16 that I have already initialized in the constructor. Here you can see the output of get state var function. Coming to the next step, I have variables and variable scope. At this point, I have already cleared in the type.sol file. Let me cover it. Here we have multiple types of variables that I have already discussed previously. That is state variable whose values cannot be changed, permanently stored in the contract. We can change, but we can't delete or remove them. These are the permanent stored value in a contract storage. These are not the temporary variables; these are permanent variables. Local variables are permanent variables and can only be accessible in the functions. Global variables, these are the special types of variables which can be accessed throughout the code. Global variable types, this is in the example I have listed here, block dot difficulty. I will discuss these variables in the next section. Here's the example for the variable types and the scope. Here's the state variable that can be accessed throughout the code. Here I'm declaring the initializing the state variable. And these are the local variables. We can't access local variable outside this function, but we can access state variable inside this function. Coming to the next point, operators and loops. Operators and loops. Just like other programming languages, here we have the arithmetic operators, comparison operators, logical operators, and we have same loops for Solidity programming language. For arithmetic operators, we have plus, minus, multiplication, division. For comparison operator, we have less than, greater than, equal to, not equal to. Assignment operator. For logical operators, we have and, or, not. And for loops, we have while loop, for loop, and do while loop, just like other programming languages. Here is the sample code for testing and running all these operators. Here I have created two variables, that is the state variables, value 1 and value 2. Here I am setting these variables a value. These are the setters for value 1 and value 2. Here I have created some functions for a demonstration of arithmetic operations. I have created add function for adding value 1 and value 2, subtract function, division function, multiplication function. Here I have used comparison operator for greater than. Uh, uh, I have created a bigger value function. Is value function for comparison of two values, either they are equal or not. Then I have created another function at, and that will add one by a loop, by a while loop, and another function that will subtract one by that will subtract 10 by the increment of one. I have created a for loop here. Okay, moving to the next step. Strings and arrays. Yeah, okay, how much time I have used? Okay, okay, strings and arrays. Strings, just like other programming languages, we have strings here. Uh, Here is the string data, string reserved keyword, then variable name and first name. We can also use byte32, which also acts as a string, but for the string we have to set the memory reserved keyword. But for byte32 we don't use memory reserved keyword. These all, but uh, Solidity also provides the casting between these two data types. For that is string and byte32. We can run these and get the uh, our required result. Let me compile string.sol and then deploy it. Uh, I have deleted all. Okay, I have deleted. So my name, my first name, get my first name, that is Osama, and get last name, that is it gives the memory result of my name. Let me check here. This is the address where my last name has been placed. So I have to cast it into string for decoded purpose. Coming to the next point, I have special variable. Oh, I missed arrays. Arrays. Just like other programming languages, we have arrays here. We can create dynamic or static arrays. Here I have created a dynamic array. The syntax for dynamic arrays: first the data type, then arrays, uh, array brackets, then memory is the reserved keyword that assigns me a memory in my uh, available resources. Then I have initialized it to a 7 consecutive blocks for uint data type. Here I am creating another for array for bytes. Here I am checking the array. Here I am accessing the address, accessing the element of the array. Here I am testing the. Actually, assert is the error handling function that will check whether or not my code is working correct or not. Okay, coming to special variables. Coming to special variables. Okay, special variables are globally available variables and provide information about the blockchain. Example: block.gas limit you into uint. It will give me returns the current block gas limit. So I have created a sample code here. I have used ledger balance